I hope all of you were wondering how to do it. Well, induction has come to our rescue. Let us see how we can prove it using induction. So what am I going to do first? I'll consider the statement P of n is every 2 power n cross 2 power n checkerboard with one square removed can be tiled using triomino. What will be the base case? It is P of 1 equals 2 power 1 cross 2 power 1, which is a 2 cross 2 checkerboard with one square removed. It looks like this. It can be tiled. How? I'm going to put a triomino here like this. You see, it is true. So for better understanding, let me show you the answer for 4 cross 4, that is P of 2. This is the checkerboard. I'm going to remove this square and this is the answer. You can tile it using triominos like this. Now, what is the induction hypothesis? It is assume that a 2 power k cross 2 power k checkerboard with one square removed can be tiled. Now from now onwards, I'm not going to mention that one square is removed. It is assumed to be true. Whenever I'm telling a checkerboard here, it means that one square is removed. So the induction hypothesis is that it is assumed that a 2 power k cross 2 power k checkerboard can be tiled using such triominos. Now, what do we have to prove? A 2 power k plus 1 cross 2 power k plus 1 checkerboard, where one square is removed, can be tiled using triominos. This has to be proved. So assume this is a 2 power k plus 1 cross 2 power k plus 1 checkerboard, this large one, and I remove one square here. Without loss of generality, I remove this square. Now, what we have to do is next, we split this entire checkerboard into 4 2 power k cross 2 power k boards. Let me explain with an example. Consider this 2 cross 2 checkerboard. Now if I expand this or if I double it, I have to double it this side as well as this side. So do you see 4 2 cross 2 checkerboards here? The same way here, we have this entire 2 power k plus 1 into 2 power k plus 1 checkerboard, which can be divided into 4 2 power k cross 2 power k boards. Pause for a minute and think how it is done. So it is divided like this. So we have 4 boards here and in one piece, one square is removed. I hope it is clear till now. Now, what does the induction hypothesis say? It says that 2 power k cross 2 power k checkerboard can be tiled. Correct? So this entire 2 power k cross 2 power k checkerboard can be tiled. Done. One is done. Now 3 more pieces remaining here. We have to tile all the 3 to say that the entire 2 power k plus 1 cross 2 power k plus 1 checkerboard can be tiled. What do we do? Look at the ingenuity of the proof. What I'm going to do here is consider the center of the checkerboard. This corner, and this corner. I'm going to consider the 3 corners here and remove it. What do we have now? We have 3 2 power k cross 2 power k boards with one square each removed. Correct? Now, it is very obvious from the hypothesis again that all these can be tiled. One piece was earlier tiled. Now the remaining 3 pieces can also be tiled by the induction hypothesis. Right? So it can be tiled like this, this and this. Now, do you observe something? What does this red part indicate? It is also another triomino, you see. So what do we get? The entire 2 power k plus 1 cross 2 power k plus 1 checkerboard has been tiled using triominoes by removing this triomino. If you have keenly observed, it wasn't actually removed. This was yet another triomino now. One square was removed and I kept on tiling the other pieces too. Hence, you have tiled your entire 2 power k plus 1 cross 2 power k plus 1 checkerboard. Hence, we see that any 2 power n cross 2 power n checkerboard where one square is removed can be tiled using such triominoes.